law. Head over to the YouTube channel, and that's where we'll be asking, or I'll be answering all the questions. I have too many things on the screen right now to keep track of, so I can't monitor Meetup. I can't monitor Facebook. There's handout notes, which I made available. I posted the links on the Meetup site, so you can check that out. And yeah, kind of made them last night, so I might have to revise them at the end. We'll see. When I was going through the notes, I realized this topic is pretty intense, so we're not going to go too crazy, and there's going to have to be further episodes or live meetings or one-on-ones or whatever you want to do in terms of learning regular expressions, because I don't actually get to the practical what exactly you're doing with the part of this tutorial, which, okay, at the end I'll throw in some stuff because I did make some programs that show some applications for what they're used for. But just learning the syntax is kind of intense. It's going to take a while. I want to begin. Someone said hi. Hello. I won't be able to type replies all the time either. I got like multiple monitors and computers set up here to do this. Pretty inefficiently crazy. I took a picture on the Meetup site of my setup when I'm doing this. I got my tablet. I got my... Wait, can I do one of these things? Let's see. Let's see if I can be super sneaky. So, yes, I got a tablet on the top here. Got my laptop, and I got another tablet, and I got the microphone. That's the setup. Wacky. Okay, so one more second. I'm going to start getting this into go mode, and we're going to begin. So just give me a few seconds. Oh yes, there's handouts right here. So basically, this link is on the Meetup site, and I sent out an email. But if you visit bit.ly/intro regex, all caps for the regex, it'll take you to the Techalicious.club website. And basically, I'm just going to go through that PDF. So if you want to follow along, you can visit Regex 101, but that's also listed in the PDF. Yeah. Good website that kind of allows you to put in the syntax and visualizes it for you. It's all about visualizing for me with the Regex because it's very, very confusing sometimes. All right, so I guess we'll begin. Welcome, everybody, to the Regex Intro. And this is an intro to magic, wisdom, and sorcery. Might as well be because Regex is pretty intense. It's a lot of hieroglyphic characters. If everybody has the PDF, I'm going to actually just read the intro to you guys. So hopefully you got that. Once again, the PDF is listed on the Meetup site. People are messaging. Let's see. Okay. Here we go. So what are regular expressions? So regular expressions, or short form, Regex or Regexp, are used for pattern matching, text manipulation, and parsing data. They're available in many modern programming language, such as Perl, PHP, Python, Ruby, and JavaScript, as well as countless utilities such as grep and software programs. Regex comes in slightly different flavors based on the programming language or application, and we will be learning the PCRE version. This stands for Perl Compatible Regular Expressions. Now, Perl, which happens to be also my favorite programming language, is kind of credited for popularizing its usage and making it pretty advanced. Regular expressions years ago wasn't advanced as they are today. And for example, PHP uses this PCRE flavor. Some software that I highly recommend. The one I'll be using for the duration and the one I use all the time, let's have a look, is called, where is it? Where's my software? It's called Regex RX. And it's for Mac and Windows. It does cost money though, but a free alternative online could be regex101.com, which I mentioned just earlier. And check out those two pieces of software. Let's see, people are pasting messages. Nobody's doing anything. Okay, so what I'm going to be checking periodically as well is the YouTube channel is a live stream, and there is the ability to there's a little chat room in there. So if you have any questions or anything, just head over to the YouTube channel that you're watching this stream on, and you're going to notice, hopefully in the bottom or something, there's going to be a little chat room, and then you can ask questions. Hopefully I'll see them because it's on a different monitor. But anyway, here we go. So regular expressions, pattern matching, parsing, replacing texts, pretty cool stuff. We're going to take it really slow, and basically I'm not going to show you the integration of regular expressions into other programming languages. It's like its own living, breathing programming language, and it exists and it is available to access in other programming languages, either by functions or sometimes it's like natively built in like Perl is. But before we get into that, we have to first understand the syntax and how this thing actually works. So as I said, it was pattern matching. So this program here is broken into the search pattern, which is where the regex magic goes, and the source text, which is what you're searching. And this thing at the bottom is the match list, which we can ignore because it doesn't really matter for this tutorial. But for example, say I want to match the word cat. How do I do that? Let's learn about literal matches. I can literally match that by typing in cat. So cat matches cat. Pretty easy stuff. Now, it's case sensitive, so if I typed in cat, obviously it's not going to match. One thing that kind of like people get confused about in the beginning is that, for example, say if I wanted to match 1-1, actually we'll do something like 3-3, and the source text is 3-3-3. You'll notice that the only thing that matches here is the first two threes, and that kind of confuses people because they ask, well, why aren't these threes matching? That kind of thing. Once a match is made, it's basically consumed, and it's no longer, you can no longer use that source text. So it moves to the next. So the 3-3 now is trying to match against the lone 3, and that doesn't match, so it's not going to happen. So that's basically literal matches. I don't think anyone would have any questions about that. It's pretty straightforward, pretty basic. Now, for example, say for example you had something like a little more complicated. We're going to talk about anchors. Anchors are, I'll show you in a moment what that means. So your source text is cat, cat, and you want it to match cat, but both cats come up. Say you only wanted to match what's at the start of the, we'll do 3 actually. We'll do 3. You only wanted to match the first cat in the sentence. So you would use something called an anchor, and this is the carré. Carré, I think that's what it's called. And what it does, basically, it says anything after it. It's anchoring this to the front. So this cat means basically start cat. And obviously, this is the only one, so it matches. Now, if I wanted to match the cat at the end, I would use the $sign, or not the 4, the $sign. So it's another anchor. It's the start and ending anchor, right? So now basically cat and then end of line pretty much. And there's only one match because that cat is sitting at the end of line. If the last thing said like dog, it's going to have no matches because it's looking for end of line cat, right? If I did this and this, like if I put the 2 anchors in, you can totally do that. It won't match anything because basically what it's looking for is this scenario. It's looking for cat alone. Hopefully that makes sense. Does anyone have a question about that, or is that pretty straightforward still? So basically, regular expressions has a ton of all kinds of wacky, they're called metacharacters like this, and they do different things. So it's pretty much all it's about is memorizing the rules of all these different wacky things. So those are anchors. There's another thing called boundaries. A boundary is basically it's called a zero width assertion. That means it affects the outcome of the match, but it doesn't actually. It's not in the match. So I'll show you what that means in a second. Now the B, the boundary, it's /B, right? Basically what this is saying is, what did I put down? It tries to match instances where a word character transitions to a non-word. Okay, what does that mean? Pretty much what that means is, if I typed in cat, 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 wait a second. Hold on, all of those would match, obviously. Okay, hold on. Let's try a better example. If I did like cat, cat, there we go, that's better. And I wanted to do cat B, it's going to match this part of it because in front of it, right here, it's transitioning from words to nothing. That's basically what's going on. If I put this shouldn't match anything. Yes. So I don't actually really use these word boundary things, but it's useful because you can pick out things. Basically, if it's for situations, a basic scenario would be like, there's a word. I don't know what's a let me think here. What's like a word that has something? I can't think of a word right now. Catastrophe. Catastrophe. How do you spell that? Catastrophe. Ah, there we go. So for example, in this scenario, you have this word, catastrophe, and you get a match because cat appears. It's basically looking for an instance of cat no matter where it appears in this text. That's not necessarily what I want, is because I just want cat alone, right? So if I do a word boundary against it, it won't match anymore because this is not what I'm looking for. But if I have a standalone cat, it'll match it. Hopefully that makes sense. Yeah. All right, I'm just going to continue. Oh, there's also a delay. So hopefully, if there is questions, remember, head to the YouTube channel. There's a chat room, and that's where I can respond to any questions that you may have. There are notes that you can download if you're just joining us now. I noticed a bunch of people are just started streaming it. I left all the instructions on the Meetup site, so you can grab all the notes from there. And let us continue. So what did we learn so far? We learned about anchors. We learned about boundaries. Blazing through this stuff really fast. Maybe I'll slow it down. But okay, so alterations is the next topic. An alteration simply means that it means something this or that. So if I typed this alteration, which is the pipe, dog, I'm looking for either cat or dog. So it's going to match dog. It's going to match cat. It's not going to match frog, for example, because it's saying this or this. I can go frog, and then it will match whatever. So basically, an alteration is just different. It's what it sounds like. It tries it from this side first, so left first, and keeps going. So if it matches this, then tries this, then tries this. That's pretty much all that is. Pretty basic stuff so far, and that's called an alteration. The next thing is called a character class. Now, a character class, what it's going to try to do, it tries to match individual characters within square brackets. So if I have the letter A, it matches only A out of the BC. If I put BC, it matches A, comes back as a match, B comes back as a match, and C comes back as a match. These different colors represent that they're basically the different matches. So if I put a capital A, it's not going to match anything because they're all lowercase, right? A, B, C. I know this sounds, we're going really slow, but we have to understand these basics before we start doing funkier things. So bear with me on this. And if you've seen this before, bear with me. A, B, F, C, of course, will match. It's going to start getting cooler because we can put ranges within character classes, which is cool. So if I type in A to Z, I'm matching anything from A to Z. It hasn't matched because they're all capitals. But if I type in, hello there, everyone, it's going to match pretty much everything except for the H, because the H is a capital. That's a little more useful. Okay. So you can go A to Z, A to Z. Now it's matching everything. Numbers. Doesn't match the numbers. Well, I had some Y's in there because the numbers aren't a part of the range. But if I add 0 to 9, now everything is covered except for the period. So these are now ranges. The ranges are, these things represent the ranges, these dashes. If you actually want a literal dash inside of the character class, you add the dash at the end. You can do that. So now I can actually have dashes in here and they will match. Otherwise, they won't match because they'll think that you're doing it in a range. All right. So far, so good. Nobody's asking any questions, making sense, hopefully. Now, here's where it gets kind of weird. In regular expressions, depending on where characters are used, they may mean different things. Now, before I told you that we had this carré that basically said match only something at the start of a match. So it only matched one thing here because we're only looking for one character, and that one character fits in the range, and it's only matching at the front. So that's what a carré, we talked about that, what that's about. But if you use a carré inside the character class, it means something totally different. It means negate the match. So pretty much anything in this character class, do not match it and look for anything that's not in it. That's why all of a sudden you see that the spaces and the period came up as matches. Pretty wild, eh? So hopefully that makes sense. But for example, let's do a little more. So I'm not like dash. There's no rush in any of this stuff. A to Z, what this is saying is it's saying match everything that's not lowercase a to Z. So as you can see, the capital H matched, the spaces matched, the period matched, and all the numbers matched and the dash matched. Because we're saying match everything that's not. Makes sense? Hopefully. Hopefully. Wackiness. So if I did numbers, 0 to 9, anything within the number range do not match. So look for anything not 0 to 9. I could just go, I don't want to match 9. So everything matches. We don't even have a 9. 8. All the 8s aren't matching. Okay. So pretty much, yeah. Crazy. Well, one thing I want to show you, I probably should have did this in the beginning. Kind of deviating here a bit, because you're probably wondering at this point, what is this all used for? So what? For example, what I use this for a lot is for scraping information or parsing data. So say you have an unstructured data set and source like this, and I wanted to pull out only valid URLs. As you can see, they kind of get kind of complicated, but you can string out something pretty detailed that pulls out only valid URLs. So pretty much this is not a valid URL because of the misuse of periods. And my regular expression kind of says, okay, ignore that and only grab stuff I want. So that's pretty much, it's basically for scraping, manipulating, and replacing text, as I said. Just wanted to show you that. I don't remember if I showed that at the beginning, but I just wanted to give you some practicality behind what we're doing here, because right now this is probably pretty nuts, but I love it. Okay. I think we're good with character classes. This is still not very useful in the sense that we're kind of only matching like one character at a time, literal matches. It's not so far not so useful, but it's getting there. To make things a little easier, or probably going to be super confusing, is that regular expressions came up with short forms for things. So you didn't have to sit there. So instead of sitting there and being like, let's go, hello there. So instead of going A to Z, or say I have something like, hello there, I like the number 3. So instead of, say I want to match all that, instead of going, okay, I got to type this whole big thing out. Oh my gosh, this is taking forever. There's actually a short form for that. All this stuff here, right, plus the underscore, is that what it's called? Underscore, underline, is represented by a simple /W. Cool, eh? So basically that's the short form. And the negation of this is a capital W. So now I'm selecting anything not within that range. So all the spaces in this case. Once again, just so that makes, I'm going to add something here. Ignore it for the time being. That's called an inline mode. I'm going to explain what that is near the end, but it's going to allow me to do comments. So I can actually start writing this out more like a program, which is incredibly useful. So this right here, this character class, if I was to write this out, pretty much, that's a lot of writing. It's equivalent if you do, it's actually if you just do this, it's equivalent. You don't even have to put the character class on it because it's implied. So that's kind of cool. That's a lot of work that's saved by just doing this. And this is the negation of it, right? There's a bunch of them. There's also the D. And the D represents anything 0 to 9. So the 3 is selected. That's very handy. The big D is anything that's not a digit. So if you wanted to, for whatever reason, in some sort of complex rule, you needed that, you can do that. These are called, once again, metacharacters. Hopefully I said that. Say, for example, you just wanted to match the tab key or something. The tab key is, let's get rid of this. The tab key is the T, right? A line break is a /n. Or is it a backslash? The S is any space. So any space means tabs could be tabs, line breaks, carriage returns, anything. That's the /s. These are all in the notes to look up. If you just want to match a literal space, you actually just leave a space, right? So what did I say about metacharacters? Character classes have some shortcut equivalents. They are called metacharacters. Here are some popular ones. That's what I said. Let's see here. Oh, the dot. I totally forgot about that one. That's like one of the most dangerous ones. The dot matches everything. As it stands by default, the dot matches everything except for new lines. Very important to note for now. So the dot matches everything but new lines. So if I just did dot, as you can see, everything got matched. Doesn't matter what I type, the dot will match it. So it can be dangerous. You'll see why in a few seconds. Dangerous because it'll match everything and sometimes very unexpected results. Now, these metacharacters, like this and this and this, what if you actually wanted to match them in the literal sense, right? Say I had source text and I had for whatever reason I needed to match this. I can't do this because, there you go. I can't do this because it's matching the go, but it's not matching what I want here. So how do you actually match it literally? So you have to backslash it, or is this the backslash or forward slash? I'm going to ask, is this, I always forget this, is this a backslash or just forward slash? Let's see what the community has to say. Anyway, so it's called escaping. So if I do this, now it's actually taking its literal equivalent. So you can do that for any kind of character that has special meaning. And special meaning characters, once again, are called metacharacters. So if you wanted a literal dot instead of anything, so if I wanted hello.com, right? But if I had it like this, everything is selected. I just want the dot for whatever reason. There you go. So that's just a rule to keep track of. Whew! Pretty intense. Jeffrey says it's the backslash. Thank you, sir. Okay. At least someone's watching. All right. So once again, forget about this. This is just something special that I'm using to allow me to, it's called free space mode. And it allows me to do multiple lines, which you normally aren't allowed to do. Normally, you have to write a regular expression out on one line. And it allows me to add comments. Very useful, though, if you're learning. Or very useful to, if you want someone to actually understand what your regular expression is about. Okay, quantifiers. Here's where it's going to start getting useful. Also crazy. So a quantifier. What is a quantifier? I'm going to show you two different quantifiers. So let's do this again. A, B, C, D, E, F, G. So as we showed you, A to Z matches everything here, no problem. But I don't want them being saved as individual matches because depending on the programming language you're going to use, it's actually going to return an array or it's going to return a whole bunch of characters one at a time. That's sometimes not very useful because why would you want that? Sometimes it is, most of the times it's not. I want to match all those characters in a row, right? So that's when you start doing quantifiers. So basically a quantifier you put at the end of an atom. And I didn't use that terminology yet. An atom means like a unit of matching. This W is considered an atom. This is considered an atom. It's all atoms. That's just regex terminology. So basically, let's try this again. A to Z, we know what that is. It matches all the letters. But if I add a quantifier, and the two quantifiers I'm going to show you are the star and the plus. So basically, what do they mean? A star means 0 or more, okay? So if I had, for example, the number 1 in this is a valid match. It's basically saying I want to match something that starts with the number 1 and has letters A to Z 0 or more times. This can be an infinite amount, and it will match it all. It also should match, since it's 0 or more, just the 1. Because it's saying match the 1, match this range within this character class 0 or more times. Now, if I wanted to do that again, but I put the plus means 1 or more. So you at least need 1 match to make this valid. So A to Z one or more times. It's just basically repeating it, right? So it's looking at each character, repeating it, and clumping it together and making this one whole match. So hopefully, as you can see shortly, this is going to get highly more useful. Pretty much, if I erase this, if I erase the source text and I erased all these characters, it's not going to match because this no longer fulfills the match. Because once again, what it's asking for, I'm looking for a 1, then I'm looking for A to Z one or more times. That is enough to suffice to fill the match. If it's a capital A, it's not going to match because it's not within the range I'm looking for. Does that make sense? I'm going to look at the chat just to make sure nobody has any questions on that, because that might confuse people. Hopefully not. Good, it does not. I don't see any interaction. If you want to ask questions or if you're confused, there is a chat room on the YouTube channel. You can check that out right now. Okay, so what else is going on here? Now it's going to get interesting. Just going to drink some water. So we could use this, and now this will match hello. Cool. My name is. Now matching each word. Neat. Awesome. If I did a bunch of numbers, it's not going to match it because it's not within the range. So I could do, for example, something like this. And now I'm looking for one or more number in a row. This becomes one set of match. This becomes one set of match. Cool. Now, the star and the plus is kind of dangerous. Well, not dangerous in the sense that you're going to hurt yourself, but dangerous in the sense that it might be pretty unpredictable what you expect is going on here. Whoops, putting this in the wrong place. I'm going to write that out, and I'm going to do something like paragraph 1, paragraph 2. There we go. So as you can see, I'm starting to write something that potentially has a little bit more use, in the sense that this is now kind of scraping data. This is like website tags. So I'm looking for website tags, and I want to find a match. Where this is probably getting confusing is why is it matching everything in one single line? Where that's not, look, if I put this down here, actually, no, that's not going to do because they're new lines. Because remember, as I said, this here does not match new lines. But if I put this really far away, it still matches. That's not exactly what I want, because what I wanted was I wanted to pull out all the p tags in this, pretend this is HTML. Hopefully everyone's seen what HTML looks like. Pretend this is an HTML document, and I'm writing a regex, particularly just because I want to grab out all the p tags for some reason. Right now, this is not doing what I want because it's not actually pulling out the p tags separately. It's pulling them all out in as one big match, and that's kind of strange. Why is that? It's because these quantifier matches by default are what they're called. There's called greedy. So it basically tries to match every instance of it all the way, and it does it to the point where it skips the ones in between. So it's grabbing this one, anything in between, all the way to the end. So. And that's because it's what's called they're greedy. Greedy quantifiers. How do we make them non-greedy? We need more sharing. Well, that's not exactly, but to make them non-greedy, what we do is we add an additional question mark at the end. Oh my gosh, this is getting crazy. So, oh, look at this one. It didn't work for here though. Oh, look at this. I didn't end the tag. So basically now this is more like what I wanted, right? Because I wanted all these paragraphs separately, and now I got them. And simply just by adding this question mark. So what does the question mark do? It makes things non-greedy in this context. So I basically, this is what I want to repeat. Oh, yeah. Jeffrey noticed I forgot the slash. There's going to be a delay between what I'm saying and what you guys see. So I got to keep that in mind. But so far so good. Basically, in this context, so we got this means match anything 0 or more times, but make it non-greedy so it doesn't match to the end, right? So that's why we managed to grab these into separate matches. Now you could use this question mark quantifier in other ways as well. Basically, it just means 0 or more kind of thing. But it's basically, it means, I'll show you. Say I had HTTPS .com, and I want it to match HTTP, but sometimes there's S's. You put a question, you put this quantifier here, it'll match it or not match it. It's basically, it's like an alteration kind of thing, but basically it's saying it's either there or it's not there in this context. If you put it beside an atom, it's either there or not there. If you put it beside a quantifier, it makes it non-greedy. Crazy. Does that make sense? Hopefully, probably not. Yeah, so basically this will match this and it will match this is all I'm pretty much saying here. So if I typed in cats and put a question mark, it's going to either match cat or it's going to match cats in that context. So whatever atom that comes before the question mark, it's like optional. That's a good word. Think of it as optional. But if you do it in the context of this kind of stuff, let's do this again, where I had this p tag thing. I need actual p tags. P tags. This could be anything really. I'm just choosing something that kind of looks useful. This is not what we want again, or maybe it is what you want, but this is not what I want because I want to separate these things between the tags. To make this non-greedy, because by default it's greedy, you put a question mark. So there we go. Whew! I'm exhausted. What else do I have written here? It's all written in the notes. I wasn't really reading it this time, but I think I covered everything that I had. I had question marks, greedy, non-greedy, optional. It's all covered. Okay. Next one. So we did the quantifiers. There's also iteration. Iteration is like quantifiers, but you specify ranges. So I seem to be putting cat for everything. I don't know why, but apparently I really like cats or something. So say I wanted to match 3 cats in a row. I don't know why I'd want to do that, but there we go. And it doesn't work. Fail. This again. Should match it 3 times in a row. No? Why not? What's going on here? What is this saucery I say? Oh, duh. I'm going ahead of myself here. I can't match that. All right. I can't. Okay. I probably did this in the wrong order, but we have to go back to individual characters. Sorry. We'll try this. I'll explain this in a second. Basically, if I wanted to do something like this and I wanted to match 4 4s, this iteration means match this 4 times. So if 1, 2, 3, 4, if it had 2 4s, it won't match. If it had this many 4s, it'll match the 2 groups of 4s. So basically what this is saying is look for a match that repeats itself 4 times. The reason why my cat thing didn't work is because it's actually trying to match the T. It's not trying to match cat itself. See? It works here because it's matching the 4 4s after it. That's why it's not working in that situation. I'll show you how to make it work with actual like proper words or other things shortly. But let's just get into the basics of iteration first. So in another one, like for example, say we have the letter A, right? And I want to match the letter A 3 to 4 times. So it's going to match. It's going to default to the most. Let's see if I put the question mark. It puts the 3. So basically, the range, it's greedy as well, and it will try to match A 4 times first. Or if it can't, it'll match it 3 times. It's within that range. So basically, it matches it now 4 to 7 times. It won't match until there's a 4. It'll match anywhere up to until you exceed it. And it will start the next match because there's 4. So basically, it's a range of matches it's trying to do. So it's trying to match A 7 times or 4 times. If you put a question mark, it makes it non-greedy, so it tries to match the minimum amount first. So the minimum amount is 4 and 4. So that's another fun thing there with iteration. You can match, what else is there? Yeah, you can. So basically, if you either do it like this, oh, wrong place. Let's do X's. Again, I want to match 2 X's, so it's going to match the first 2 X's. And it's going to match the second pair of X's, right? You can do ranges that have an infinite amount. So basically what this means is it's saying that match it 2 times or infinite times, but it has to have a minimum of 2. So if I had 1 here, it won't do it. If I made this 3 and if I had 2, it won't match it. If I have 3, then it will match it. Then it will match everything after that. Just it'll keep matching because the minimum prerequisite was fulfilled. Whew. Intense. That's iteration. Now, what's going to make everything... I'm going to look at the questions. Any questions? No questions. All right. Either everyone is confused to the point where they don't understand anything, or everyone got it so far. Excellent. The next thing we're going to do is capture groups and non-capture groups. This is where everything is going to start getting awesome. And this is all going to start making sense now. So a capture group does 2 things. It clusters atoms together, and it also captures them to memory. So for example, if I said cat, right, and I put parentheses around it, it does what you'd expect it to do. It's matching cat with cat, but it's doing something special to it. It's saving this as a variable to memory. And the variable it's saving it as, I'm going to put this mode up again, just so I can do comments. It's going to save it as a 1. Now that's useful when we start getting into things like replacing things. But for now, you could still use this saved variable in the match. Say I had cat and cat, and I wanted to match 2 instances of it. I can do this now, the iteration, because it's basically now iterating anything in this atom. So before, remember, it didn't work because I just had it like this. But as soon as I put it in a capture group, it's saving it to memory, and it's applying this iteration to this. So that's kind of cool. So it's matching 2 instances of cat in a row. Pretty awesome. And it's saving it to memory, which is cool. But let's see here. If I wanted to do, what did I wanted to show you? Oh, yes. Since it's saved to memory, you can actually invoke that variable anywhere in your match. So we've saved cat. And if I do a \1, that's invoking the variable number 1. And so it's the same thing as doing the 2 in this instance, because I'm basically, so I had like cat and cat. I'm just calling that variable, calling that match again. Erase this. It's not going to match anything. Basically, it's saying cat, cat, cat. Cat, save to variable 1, call variable 1. What's in variable 1? Cat. Call variable 1. What's in variable 1? Cat. There's only 1 cat, doesn't match. 2 cat, doesn't match. 3 cat. Oh, yeah. 3 cat, go. There we go. So that's a capture group, which is pretty cool. Where this is useful for example, is if, say, for example, I had HTTP, something like HTTP some url.com, right? And then I'm trying to figure this out. I'm just going to make, this is not a really good way of doing it, but we'll do it this way. Let's do it actually something like this. There we go. Say, for example, okay, so I'll explain what I did here. So HTTP, it's a literal match, colon, data, literal. I basically said match anything, right? We've seen this before. Match anything, 0, we'll put a plus because we want to match something. 1 or more times, make it non-greedy, all the way to the first space. So as you can see, it matched this URL. Great. But I don't want to deal with this all this stuff around it. I just had it there because basically, for example, I want to. If there's a bunch of source text around it, I need to figure out how to separate this from the rest, and that's why I added this information. But I don't want to deal with this HTTP stuff at the end of the day. I just want to deal with this. So what I would do is I would put a capture group around it, and now it's saved as a variable number 1. Variable number 1 actually stores some url.com by itself. And then in the context of a program, you can start doing things with this. So it's pretty cool. I actually wasn't going to include replacing, but regular expressions can also do replacing. So basically, if you just wanted to, like, say, for example, I wanted to replace all the URLs with HTTPS, right? I would invoke the variable, And then you'll notice that the result will add an S to it. So you can do things like that as well. So it's useful to grab things into capture groups for various reasons. I can show you some things I use it for later, but for now, this is basically, I'm just trying to teach you the concept of what's going on here. So I didn't introduce replacing, but that's also another thing that makes regular expressions highly useful, is the ability to be able to replace things. So as you can see, just to explain what's going on here again, literal match, wildcard craziness, one or more times of anything, non-greedy up to the first space. I only want to capture this into variable one, it becomes some URL, and then when I paste it back, paste back the contents of variable one. Now, if I have multiple capture groups, so let's do something like this. Multiple capture groups, basically, if you have two parentheses, it starts saving it as variable 2, variable 3, variable 4. So let's give an example so it makes sense. Say I got something like, let's do sentence, well, I should write it on the bottom, not the top. Say I do sentence number 1, sentence number 2, right? And then I want to do something like, let's do match everything up to sentence number 1. And then capture that in a group. Capture this into a group. And then I want everything sentence number 2. Capture that into here. So let's see if this is making sense and if it matches. So the whole thing matches because that's what this is. So basically what's going on here is that match anything. This is probably not a good way of writing this, as I said, because these are dangerous, these wildcards. So let's do this a better way. Actually, we'll do it this way first to show you the concept, and I'll do it another way. So basically, I'm saying capture anything up to the period, non-greedy. If I made this greedy, it would capture everything incorrectly, not the way we wanted to do it. But basically, I'm capturing everything. So it's basically capturing this, right? And then it's not capturing the period because it's not in the capture group. So I'm capturing this to a capture group. I'm capturing this to a capture group. So it's created two variables, variable 1 and variable 2, right? So if I went to replace and I went variable 2, variable 1, you'll notice that it reversed the order of the sentences. So you can start manipulating things in very intricate ways. I'm checking the questions. I've got no questions so far. But pretty much, yeah, that's what's going on with that. Probably a better way to write this that's not as confusing would be something like this. Let me show you. So basically, let's do word characters and space characters, word characters and space characters, and add pluses to them. This should make a match out of this, right? So now I'm going to say that it has to start at a word character, and it has to end with a period in order for it to match or something. And then I can put capture groups around this. So it's basically the same thing, but it's not as dangerous. I'm calling it dangerous, but not as wild as the wildcard approach. So I'm matching anything that is a word character. And once again, word characters are things like this, right? Yeah. So it's matching all that. Probably a better way of writing it. Hopefully you can see kind of the power of what's going on. This is very basic stuff, but we'll build upon this shortly. I'm actually exhausted. How long have I been doing this for? Whew! Regular expressions, eh? It's killing me. Okay. So what do we got? What do we got? We did back references, I think. Oh, non-capture groups. Say, for example, you wanted to do something like, I don't know. Say you have a bunch of text or something. And a non-capture group is you add this colon thing here and a question mark. A non-capturing group has the same effect of grouping things together for quantifiers, but it loses the capturing to memory. So you don't want to capture stuff to memory all the time. You don't need to create variables all the time. So if you still want the power of clumping things together, but don't want to start saving variables to memory, you use what's called a non-capturing group, is what I showed you here. So basically text, if I did something like this, I can apply a quantifier to this, or an iterator, and now it's applied this to this entire non-capture group. And if you didn't have that, once again, it would only apply it to, not going to work because it's just applying it to this. But yeah, so far so good. So far so good. Whew. Oh my God, I actually did negative lookarounds. Advanced topic. So this has been a whirlwind introduction, obviously, to regular expressions. And now we're going to kick it up 1,000 notches and do negative lookarounds, which is probably not something I should be showing you at the moment, but we'll do it anyway. So there's 4 different types. These are called zero width, assertion, negative, positive lookarounds. So similar to the word boundaries and similar to the anchors and anchors, the start and stop anchor, these things are able to look around and not affect the result, but not be included in the result. That's all nonsense until I show you what it is. So say, let's do something simple. Let's stop saying cat. Let's go dog. Dog, cat, or something. Dogs and cats don't get along, so I don't want to match that together. Dog, cat, that matches. This should match. Should it not? No, it doesn't. There we go, because it's a space. I can't use spaces in because I got free space mode on, so spaces don't count as anything. So I have to escape the spaces in this instance. If I remove this, I probably should be able to do spaces normally. No, I can't. Okay, so never mind. If you want to do spaces, oh my God, what's going on here? Try this again. Dog, cat. I'm actually just gonna say use any space. Remember the meta character for space. Dog, cat, that should match. No match is found. What's going on here? Is there something missing here? My regular expression thing went crazy on me. Dog, cat. Is there some option on here? No. It's gone crazy. I'm going to close this. Something went nuts here. I don't know what happened there. Let's go new. Dog, cat. Dog, cat. That's better. Program glitched out. Ignore what just happened there. I'm going to do this. Space. Okay. It happens, I guess, sometimes. All right. So what's going on here? What are we doing here? Negative lookarounds. So say I want to match dog only if it's followed by a space and a cat, and that's it. That's all I want to do. So what I'm going to use in this scenario is what's called a positive look ahead. You know what? I don't want to do positive look aheads right now. This is so confusing. Okay, we'll do it. Whatever. This is fine. All right. So this is a positive look ahead. It's a lot of syntax. It basically looks like a capture group, right? Basically everything in regular expressions, that this is a capture group, but as soon as you put a question mark inside of it, it has special meaning. So it's no longer a normal capture group. That's when we added this colon thing. Now it became a non-capturing group, as I showed you before. For a look around, if I add a equal sign, that means look ahead. So dog and look ahead. So if dog is followed by this, it will match. So that means if dog, sheep won't match. But saves you the trouble of having to pull things out with capture groups and stuff, because it's basically doing the work looking ahead for you. Another way you could have done this is pretty much you could have made a capture group. Actually, no, you couldn't do it that way. So that's this is actually pretty awesome. Now, positive look aheads for the win. Hopefully this makes sense what I'm saying. But basically what it's saying is this is dog, and then look ahead, and if dog is followed by cat with a space, then match it. And this is not there, so it's not going to match. To negate it, you just put a exclamation mark. So now it's saying that dog followed by cat and a space, and cat won't match, but anything else will match. Dog, cow, dog, holy cow, oh my God, oh my God, oh my God, oh my God. It doesn't matter. It'll match, except it will not match this. And this, you could even do, you can do all kinds of stuff. You can do ranges. Apparently can't. Let me see here. Is this working again? Yeah. Okay. Sheep. Yeah. It will match this, but that. Okay. That's fine. It should be able to match one of these, though. It didn't. That's interesting. Let's get to that later. Another thing you could do is dog. Let's see here. That dog. There's a negative look behinds. So in this situation, it's the same syntax-ish, but I've added this thing. So it's like, it's actually kind of cool because it's like, look this way, right? So question mark, look this way. And if there's a space, match dog. If there's a cat and a space, match dog. If I typed in sheepdog, won't work. Crazy dog, won't work. It's looking for this cat match before it. And that's a negative and positive look around. Well, another thing you can do is you can negate this, meaning that if a space and cat come before it, then don't match it. So it would match sheepdog, crazy dog. That's kind of an advanced thing. Not too many people even use lookarounds. I use them because I think they're very powerful. But yeah, that's probably, this is just learning it. So capture groups, non-capture groups, positive look ahead, negative look ahead, negative look behind, positive look behind, negative look behind, right? That's regular expressions is all about just like crazy hieroglyphical nonsense like that. So yeah, woo, exhausted. So I guess one of the things is what I've used it, but I didn't explain it really. These are called modes or modifiers. So this is an inline modifier or mode, right? That's what it's called. And there's different ones. So you've seen this one before. This is just free space mode, meaning I can actually like do multi-line stuff and I can leave comments. So it's pretty cool, right? There's this is case insensitivity mode. So say we did a match like this. Remember this good old match way back in the beginning, AB, and I had ABC. Now all of a sudden, this won't work because it has to be beside it. But if I had the X, then I could do that because that's free space mode. But if you don't have the X, everything has to be in a row. So A to Z will still match the capital A, capital B, and capital C because it's case insensitive mode. Pretty cool. Another one is the S. So what it does is it changes the effect of the dot. Remember the dot was everything but a new line. Now the dot will match everything, including new lines. So it becomes really wacky. So it actually new. So if you don't have this S, it'll just match one at a time. So that could be useful in certain scenarios, but be careful if it's turned on. Sometimes you can have undesired results. The M modifier changes the way the caret and the $ work. Okay, so basically what happens is normally if I did this and I did ABC, right? Let me just see if it's going to do it differently. No, the mode is already turned on somewhere. Let's see here. This one, here we are. What is going on here? String begins is line begin? Nope, that's not it. String end is line end, greedy mode. This program itself has a bunch of ones turned on already. Like these are modifiers that are turned on by the program, and the modifiers that I put on kind of override it. So right now these aren't, there's some modifiers in place right now that's overriding the normal how this is supposed to work, which makes my demonstration confusing because it's not functioning as it's supposed to be. Oh, it's great. String is lines begin. There we go. Okay. This is more of a default. I should have done this before I started. Anyway, if I did this ABC, that basically is what it's saying. Remember we were doing this in the past. But what it's really saying is it only wants to start at the beginning of the string file. So the only match that comes up is this one. If I added it here, it'll match the bottom one. So it's because it's matching, it's basically starting here, matching ABC. And this one starts at the front and matches ABC. And those are the anchors, which I showed you in the beginning. But if I use the M modifier, basically it's saying that this now represents start of each new line. So that's why these are matching now. They would match as well if I did this, because it is still at the end of the line. But if I added, like, for example, like this, you'll see it's only matching these two because it has to be end of line, end of line. And without the modifier on, it's only matching the very end. There you go. Matching the very beginning. M modifier matching turns it into matches each line. Okay. People are still watching. Pretty cool. Thanks, everybody. Hopefully this made sense. Those are a bunch of modifiers. You can even put them all at the same time, like this. Nice. They're all on right now, the ones that I showed you anyway. There's more modifiers. There's more metacharacters. I haven't gone into everything. I just wanted to go into ones that will kind of get you started on something. But let's do something practical with replace. Feel free to ask questions now, or if you want examples of anything in particular, because I can answer them. What I'm going to do now is I'm going to show you some applications for all these things and how I do it, what I personally use them for in programs and things. But if you want me to show you something again, if you want to meet on a one-on-one and have me show it to you again, I can do it. If you want to meet in a small group and go over things, what I was thinking is of doing a small group and like pick a case study, like let's make a scraper, let's make a thing that logs into a website, let's do something cool. But say you're doing something in PHP or something with form validation where people are trying to put in sneaky nonsense into your web form, you know how the SQL injection, all that. You could use a function or something, but say you don't want to use a function, you want to be really cool and you want to use like a regex. So say somebody enters in something in a text box script, bad code goes here or something. You're like, I don't want that in my, I don't want that. I want to validate this code. I want to remove all these bad tags, and I just want the text itself. So you could write something like, let's see, let's figure this out on the fly. So I want to grab all word characters. Yes, I do. I want to do all kinds of punctuation. So let's do something like this, and then sure we'll do dashes. So that's what, those are the characters I want to grab. And then I want to be like alteration. And then I want to do something like, let's do this, alteration dot, and then do that. And then, oh, we got to put this on it. Did I just blow your mind? So, oh, let's do space. So pretty much what I just wrote here is a pretty rudimentary code sanitizer for HTML forms on the fly with regular expressions, no functions. Pretty badass. So what it did is it identified anything as a script bad with this tag. So basically I said, I'll go through what this means. It's kind of like, what? I'm only grabbing one character at a time, as you can see. So I'm looking at things one character at a time. So if, let's turn this mode on so I can do comments. So pretty much if it has, let's see, if it has anything from A to Z, 0 to 9, underscore, a period, punctuation marks, should probably add a comma in here too. I don't think I have to backslash these things. I just did it just to be safe in case I have to backslash the period though, because it has special meaning, but these characters don't have any special meaning. I'm going to go bad code goes here. So it's basically looking for all this stuff in any kind of space. And then it's saving it to memory and then pasting it. So it's reconstructing the sentence as it goes. If it encounters this thing, this is not within the range. So this alteration fails. It goes to the next one and says, okay, anything starting with a start tag all the way to the end tag, match it. But then it goes over here, and the replace pattern is not replacing anything because I didn't save it into memory, so it just gets discarded. It gets destroyed. It's gone. So anything that's in a tag, in a sense, is destroyed. And then I did another alteration just in case I missed any wacky letters that weren't in this range, and then also match them. And then when you go to replace, it's not saved as number one because number one is saved only for these. So it's basically lost. It's just destroyed. So I'm destroying any characters that aren't within this range. It's a very sneaky little trick I came up with. So pretty neat. There you go. So that's a pretty useful application. And we can put that into this program is great because you can be like edit, and then you can be like copy pattern as PHP code, and we're good to go. And then we can just like go into some program. Let's get to it. Do I have a program up here? Let's go into here. Yeah. So I can be like, it's going to put it into a function called preg replace, right? This isn't, we don't need this. Oh, I see what it did. It saved my thing. It's like this. Yeah, there we go. So that's the PHP. I don't really write things in PHP, but let's see if I can figure it out. I can show you a practical application of this on the fly. So let me see. PHP is like what? Like this? Yeah. Okay, so what are we doing here? We need a source text, which we don't. Oh, source text. So say we got source text equals, what did I have? Like I did this nonsense script, and this can be like an input. You can make this whatever you want. Bad code here. Let's see, /script. So instead of the source text could be grabbing it from a form or whatever, or grabbing it from some sort of input, the user input, instead of a variable like I did there. I don't need this stuff. What's this limit count stuff? Forget that. Okay, so pretty much if I go echo source text, text, not test, is echo a command? Oh, something is not looking right here. Oh, I see. It doesn't like that. That's not going to work, man. That's not going to work, yo. There we go. That doesn't work at all. Let me see here. Let's see what's going on. Source. Oh. Okay. We got this. This is wrong too. Nope, that's wrong. Let me write this from scratch. Something's goofy here. So I'm on a total tangent here. This was not a part of the plan what I'm doing, but now I want to do it just because I want this to work. So let's do this. Once again, I don't write things in PHP normally, but here we go. Source text equals script, bad code goes here. In PHP, there's a function called preg replace, which performs the replacement thing. So what it's saying here is basically it's taking your regex pattern. It's here's your replacement pattern, and this is the text you're actually manipulating, as far as I remember. So if I was to write this again, I would go plus this. So I'll just do one of these because those are the only things I'm really using in this. It's basically the same thing I wrote before. And then we can go something like this. Let's just see if this works. Doesn't work. Do I do something like, did I spell something wrong? Business fail. Maybe I have to do something like source text equals preg match. Maybe it has to rewrite it. Yeah, that was the thing. Okay. So the missing step here is that I had to assign whatever it did to something. So I signed it back to the variable that I put in. I got it now. And why I added these things here is that in PHP, I'm way off scope. This is totally random. In PHP, I'm adding delimiters. You have to add some kind of delimiter to differentiate a regex for some reason. I don't know. You just have to do that. All programming languages, pretty much, you have to put a delimiter in. And so I picked the @ sign because I'm not using it. And if I was to write this again, how I did it in my other one, this will actually work now. If I go like this, and I do this, and I do this, or maybe it won't. Yes, there it goes. So bad code here. So there you go. It's working. So there's an example of some kind of what is it? A sanitizer you can write. I've just sanitized input and got rid of tags. Here's what I wanted us to work towards with this course. I wanted us to look at, let me see here, URL parse. Yes. So this is what I came up with for a URL parser. Very complicated. We can rebuild this from scratch if you'd like. So I have this source text right here. And what I want to do with it is I want to pull out all these URLs. Some of these URLs aren't valid because look, this isn't a valid URL. .fake. No, you can't have that. I don't think you can start with an underscore. I think that's a fake.com. So how do you write like text that pulls out only the legitimate URLs? So we're going to apply all the rules we've learned, and we're going to do this right now. Do we still have people watching? We have 7. We lost a lot of people, but hopefully you guys got something from it, and this wasn't it was okay, but we'll keep going. So the first thing I did is I turned on some modes. I turned on multi-line mode. Don't even need that really. Case and sensitivity mode is good, and free space mode, I like that one, so we'll leave those ones on. So easy part, HTTP. I showed you this from before. I'm going to do this, so it matches HTTP or HTTPS. As you can see, a whole bunch of stuff came up, literally matching this. What else could we do here? We could do the wild, crazy stars, but that's kind of difficult because, as you can see, it's matching all kinds of things that aren't right, and that's not really what I want to do. I could go match everything up to a period, do an A to Z, and then duplicate it 2 to 8 times. I could do that because I think that kind of looks a little better, but a bunch of things, as you can see. Well, no, it's actually not bad. Well, no, it's not grabbing the last thing, so that's not really working as I want it to work. So that kind of sucks. I could do like this. Nope, that doesn't work either. This thing took me a while to figure out, but I think what I did was I did A to Z. Do that. I can do capital A to Z. It doesn't matter. We can do words. We'll just do the word thing. So words represent A to Z capital, A to Z small, 0 to 9, and all those shenanigans. So that's fine. We can do, that's in URLs, I know that. Periods are in URLs, I know that. Underscores are in URLs, that's already covered. We can plus it. So that's not bad. Pretty much, if you just wanted to grab something that looked like a URL, that's pretty good so far because, yeah, that's pretty much what we needed. Some of the stuff is invalid. I can use my forward negative look ahead trick. Say it can't be this. We lost some fake URLs. So what I did here, because it's probably getting confusing already, is that so after this, it cannot be a dot. And that's true because that's not a valid URL. Also, look, it can't be one of these either. So we should put a character class and add, it can't be an underscore in this situation. Nope, it can't be one of these either. So we've just knocked out most of the URLs that were bad. That's not bad. It's pretty good. Now, what else is not working here is this one. Look at this, because URLs can't contain 1, 2, 3 at the end. So we can't have numbers in a URL, right? So I'm going to match this up to the dot. So all this stuff is in effect up to the dot, And I want to say that basically A to Z, I'll just do capital. It doesn't matter because it's case insensitive. It stands up nicely. 2 to 8 because those new domains have a lot of characters. So I pretty much pulled out now everything that's valid. That was not bad. That was easy. Using all of the rules we learned. And so this was a literal match. This was an optional one, literal match. I used a negative look ahead saying that these cannot exist. So from this character looking forward, anything in this character class cannot be there. And then after that, just say any word, any period, any dash, any underline, match, and like quantify it 1 or 0 times, 1 or more times. Match it all the way up to here, and then character class A to Z 2 to 8 times, and it stripped out this one as a possible match. Whoa! Isn't that crazy? Crazy. So that's pretty decent right there. Pretty much. I don't It works for our scenario. I'm sure there's other things that you could add that would break it, and then you just add to its complexity. For some reason, when I was working on it, I came up with this one for some reason. So I was really like, I think I was really going overboard with like making sure that things at the end didn't match and this match. But I don't think that's really necessary because this seemed to have done the job pretty nicely right here. So there you go. That's a pretty useful thing. And if you put that into a program, scraping out URLs, if you're searching source text, you can scrape emails. It's not just scraping too, just finding sentences of certain lengths or something. All this kind of stuff can be used with regular expressions, changing sentences, changing code on the fly. Yeah, so questions? Anything? Yeah? No, I guess not. Did everyone understand this? Like, at least a bit of it? Like, did it make sense? I don't know if I went too fast, so sorry about that if I did, but yeah. All right, well, nobody's saying anything, so I'm going to shut her down. Shut her down. Yeah. Thank you for watching. And that's it. Take care. Check out the other Aliciouses if you want. It's at alicious.club, and there's links to everything. A team project sometime in January might be nice. Yeah, why not? We can do that. We can get together and we can put something together and show some use cases for it. And I like making things that when I learned this regular expression thing, I learned it by doing like just picking random things that interested me. Like, I want to grab all the URLs in this document. I want to match this text. I want this to do this. I want to replace this with this. I had to do a whole project where there was really bad HTML. And I was like, this is daunting. And I used regular expressions to go through and do everything for me. And it was just like easy. And then another thing was like I used them in there's a ton of files that were renamed incorrectly. Like they had it was copying from a Windows system to what's that Windows? What is it called? It's like it's their version of Apache. II something. Why does it escape me right now? Whatever the Windows. Somebody has to know what this is. The Windows version of it's their web server thing. It's like I something. IIS. Is that what it is? Whatever it's called. They basically, in the Windows side of things, capitals, case sensitivity is not so important. But when I ported it over to Linux, a lot of things broke. So I had to rename a ton of files. And the best way of renaming the files with regular expressions and some Linux command line tools, and it just went, did everything. Seconds. Amazing. All right. Well, that's the end. Thank you for watching. And I will hopefully see you soon at another Techalicious event. Techalicious, yeah, Techalicious. And once again, if you want to check out alicious.club. Special thanks to Jess. If you know who Jess is, she's going to be teaching an introduction to Illustrator next year in Techalicious. She designs all of our awesome logos. And Techalicious is having an event today at the Madison right now. So if you are not doing anything, check out meetup.com/Geekalicious and sign up. And this is the Miker signing off. Have a good day, and thank you again for coming or watching. Take care.